Hello. Yeah, I'm Clement Sam, representing Group 4, and then we are presenting on Chapter 4. Chapter 4 has quite a lot of interesting topics that we'll be touching on, and I'm very excited. So, these are our group members. I'm Clement Sam, the one presenting our group members. So, as I said, this chapter contains a lot of interesting topics, and we'll be presenting on our user interface designs, software design, and then software design techniques. So this chapter is actually a very interesting topic. So let's get right on. So starting with designing user interface system. So Martin LeBlanc, he's the founder and CEO of Icon Finder, and then he said an interface is like a joke. If you have to explain it, then it's not that good. So if, for instance, imagine you say a very interesting joke, and then you actually expect everyone to start laughing, and then right after saying the joke, nobody starts laughing. Then in order to convince the listener to laugh, you try to explain the joke, then you want the listener to actually laugh. And then if you have to explain a joke to someone, it's not a good joke. That means it's actually not a good joke. So my Martin LeBlanc liken it to a user interface. So a user interface actually, it's just similar to the analogy, the joke analogy, and if you have to explain exactly what the user is supposed to do, you have to include quite a lot of manual, explain every little detail about the user interface, then it's not that good. Because with user interface, it should actually be self-explanatory, and then even without a huge heavy manual, the user should actually be able to know what to do. Every little detail should be self-explanatory. So user interface, and then we are saying that a user interface or the UI of a program is responsible for the display of information to the user, and it also handles the input from the user, abstract characteristics of UI. Okay, so the user interface actually focuses on what the user might. It actually focuses on anticipating what the user might need to do, and then you ensure that the interface has elements that are easy to access and understand, and those elements should be easy to use, and then they should facilitate the actions that they represent. So the UI actually brings together concepts from the interaction design, visual design, and then information architecture. So as a UI designer, you should be able to what you are designing should be able to anticipate what the user would expect, and then what the user might actually would actually expect each detail in the user interface to do. So well, and then we said the abstract characteristics of the UI include user satisfaction, efficiency, and then easy to use, just like I said. So the UI should be easy to use, and then every little detail should actually be self-explanatory. The user should be able to grasp everything, even without a heavy manual. And then the UI enhances interaction between various systems and users, and then it allows the users to manipulate and monitor the system. Okay, so the UI actually abstracts. That's quite a lot of abstraction. For instance, if you have a sign-in page, and then when the user enters the username and password and clicks on sign in, that what happens at the back end is actually abstracted from the user. And then one thing that as a UI designer you should actually have in mind is that the user doesn't care about what the system does at the back end. The user doesn't care whether your system saves the configuration obeys the SDG config rule. It doesn't. The user doesn't care about those things. So the UI actually abstracts those things that happens at the system level, and then the user only interact with the user interface, with the UI that you have shown him, and then whatever the user does, and then whatever happens at the back is actually abstracted from the user. So it allows the user to manipulate and monitor the system. And then, okay, so let's come to our user interface design. User interface design, and then the UI design refers to the visual arrangement of the elements that a user might interact with in a software or technological product. This include control buttons on any machine, such as microwave or visual layout of an app. The UI design is very essential as it directly affects the usability and user experience of the said system. Okay, so just like I said earlier, the UI interface design actually focuses on it actually focuses on anticipating what the user might need to do, and then what the user actually expects every button or every information shown on the UI should do. So as I said, you consider the usability. You make sure that you keep it simple. You make sure you keep the UI simple. I think most of the time as a UI designer, you are tempted to add a lot of things that the user might not even need, that might not even convey any proper information to the user. But you'll be tempted to include a lot of buttons, you include a lot of colors and all that. As a UI designer, these things happen a lot. So with the UI design, you are actually anticipating, you are kind of predicting what the user might expect, and then what the user actually expects, and then what the user might do. So you actually you test. For instance, it's like testing as the user. So you yourself, you're actually the user. So for instance, when you visit a site and then you see quite a lot of things out of place, you yourself, you would actually complain. So when you are designing a system, you try to behave like you put yourself in the user's shoes, and then you try to design the system just like how the users would expect it to behave. Okay, so the UI is very essential as it directly affects the usability and user experience of the sales system. So mostly when you are designing a system, the most important aspect of the system is the UI design, although the logical aspect of the system and everything, all the business logic actually lies at the back end. But when it comes to usability, it is the UI that considers that, because you can create a very good you can create a very good system with you might have implemented a lot of algorithms and data structures at the back end and all that. The user doesn't consider all those things. The most important thing that the user considers is the UI design. So it actually directly affects the usability and the user experience of the system, no matter how good you have designed the system. Okay, so the user specification of the UI. So the user interfaces are implemented based on the user's needs and system requirements. So the user interfaces implement an application logic and guides the user to interact with it. And then the user's perspective is essential in designing the UI because it helps implement methodologies for user-oriented systems, and then it aids in development of a system that meets the user's needs more readily. Okay, so the user interface is implemented based on the user's needs and the system requirement. Okay, so just as you are implementing the system, you are trying to make sure that it's actually it is readable, and then you are making sure that it satisfies the user's needs. You make sure that it also follows the system requirement for the whatever system you are designing. You make sure that it actually follows the system requirement. And then if let's say you are designing let's say a social media app. Let's say you're designing a social media app. For instance, you're designing a social media app, and then within the social media app, you have let's say added on the navigation button. You have, let's say, when the user is not logged in, you have login, sign in, and then let's say you have added visit VLE on the nav bar. Now you see, you realize that it doesn't actually follow the system requirement, because what we actually want is a social networking site. So when you visit the site, you expect to see, let's say, when the user is not logged in, you expect to see login, sign in. So you make sure that everything that you add follows the system requirement and also satisfies the user's needs. And then the user's perspective is essential in designing, because it helps implement methodologies for the user-oriented systems, and then it aids in development of a system that meets the user's needs more readily. And then it is necessary that, okay, so efficiency of the user interface. So it is necessary that the system designers address the needs of their users. Efficiency deals with the ease with which a UI allows users to perform specific tasks. Okay, so when designing a UI or the user interface, you are designing the user interface, you consider the efficiency at which a user will be able to easily interact with the UI. So the user should be able to easily interact with the UI, should be able to readily access each particular modules of the app. They should be easy to access. So every part of the system should be easy to access. You make sure that there are, for instance, if you have a login button, the login button should directly send the user to a login page. It shouldn't send the user to a sign-in page. When the user clicks on sign-in page, it should go to the sign-in page. If the user clicks on sign up, it should go to the sign up page. So you make sure that the UI is easily and then it's easy to be accessed, and then they perform specific tasks. So you make sure that just like I said, if the user clicks on a particular button, it should do what it is expected to do. You shouldn't add so much abstractions and all that. You try to you add, let's say, a register sign up page, and then at the sign up page it is taking the user to the home page, and then like a whole lot of things. No, it should perform a specific task. And then mostly in software development, we have something we call the solid principle. So mostly this mostly applies to object-oriented programming. So with a solid principle, you make sure that each module performs a specific function. For instance, if you have a particular function, that function should perform a single task. It should have a single responsibility. If it is producing a side effect, it should produce a side effect. It shouldn't produce a side effect and then make changes to the system. Whatever it is doing, like it should perform one particular function. So if you design a system and you realize you have one particular function performing several tasks, you make sure that you break that function, you make it as simple and very small as possible. Okay, so efficiency also deals with the time system requires to perform a specific task, and then the performance of an application is key and contribute to the general user experience. Okay, so when you are considering, when you are designing the user interface, you also consider performance of the application. Well, I think mostly the performance directly comes from the. It actually for a system to become highly performant, it depends on a lot of things. It depends on it can even be an infrastructural problem. It can even be a problem directly from the backend, the language you are using. And then when it comes to the front end, you consider using the proper caching method, both at the backend and the front end. You use proper caching method, and then even there are, for instance, if you would have to minimize the size of static content or static files like images and all that. You have to consider that. And then sometimes you would have to consider, let's say, if your site loads several images. If let's say at the home page, we have sites photo sites like Pinterest. You see that for Pinterest, it's actually for hosting photos. Okay, so let's say at the home page, when you visit Pinterest, you see several images there. So that means when you visit the home page, it has to load images. So in order for it to be performant, the images are not loaded all at once. They are loaded as needed. So let's say if there are several images on the site, when the user scrolls to that part, the image loads. When the user scrolls to the part where it needs the image will load. So that one, it is another way of making sure that the system is performant. Just like how Facebook does. When you visit when you go to Facebook, you see that Facebook doesn't load all the uh, all the posts at once. So as you are scrolling, and then the images will be loading, and then the post will be loading. That's one way of making sure that the application is performant. So these are some of the ways. So the performance application is key and contribute to the general user interface. So you have to make sure that you adopt the correct methods. You are adopt the right methods to ensure that the UI of your application is highly performant and efficient. And then meeting the needs of users is one of the most important factors that needs to be taken into consideration. So you have to take into consideration the performance and then the efficiency of the system, and then you make sure that it meets the needs of the users. Okay, so we come to the types of UI. So with the types of UI, we have three common types of UI. So we have the graphical user interface, we have the voice user interface, the VUI, and then we have the multimodal user interface. So we'll be taking them one by one. We explain them into details. So we start with the graphical user interface. Okay, so this interface makes use of graphical icons, menus, windows to represent information and action to the user. They are intuitive and user-friendly and have revolutionized human and computer interaction. Okay, so the graphical user interface has actually evolved. It evolved from the TUI, where you would have to type commands to interact with the system. So, for instance, if you want to create a file, at first you would have to write several commands. Actually, that's my favorite. You would have to write commands to use the TUI methods, but the graphical user interface actually presents windows and then graphical icons. It presents icons and menus and navigation bars and all that to make sure that the user can directly interact with the system without having to type commands to interact with the system. Mostly what happens is when the user with the user interface, when the user clicks on they are just abstraction, because when the user clicks on a particular icon, indirectly the user is actually directly interacting with the system. The system will still uh, interact with the system using commands. Yeah, and then they are very intuitive and user friendly, and like we all know, it's actually revolutionized the human and computer interaction. So instead, right now, you see, at first, you would have to understand and then know commands before you be able to use a computer. But right now, with the graphical user interface, everyone can use the computer. Everyone can use a computer. As long as you can read and write, you should be able to use a computer. Even to the extent, even if you can't read and write, there are still even the graphics would explain stuff you would really easily understand. Sometimes when you visit the site and then the site's in a different language, yeah, sometimes you even just seeing the icons, you know that okay, they should perform this task, just like that. So they enable a user to easily exchange information between the software using cut and paste or drag and drop, like click, um, select, and all that. And then the type of user matters. So young children are likely to prefer pictures to words. Okay, so mostly when you are designing a UI, a user interface, you consider the target audience. You consider your target audience. So if your target audience are children, are kids, then you should know that they have to include a lot of pictures instead of words. You have to include a lot of pictures instead of words. If you are considering experts, if you are considering experts, then since you already know your target audience, so you can even design it as a TUI, and where they would have to use a terminal. That's also another option. And then if you are considering, so mostly you have to look at your target audience. Okay, so let's move on. And then we have the multimodal user interface. So the multimodal user interface uses the combination of two or more different human senses to interact with computers. And then the computer focuses on finding information, finding the needs of the interaction model for people with disabilities by using different human modalities so that they perceive and control information in efficient and effective ways. So an example includes touch. So right now we have touch phones where you use the touch screen. We have braillets, like we have we have brailles for the blind and all that. Okay, and then we have the voice user interface. So the voice user interface is the interface to any speech application, controlling a machine by simply talking to it. Until recently, this area was considered to be artificial intelligence. Actually, voice user interface actually were even there before AI, because we initially had speech synthesis, where you be able to translate the voice. You transcribe directly what the user says, so you can just transcribe from the voice to text. And then you could use I think Google has a framework, Google speech synthesis framework, where you could actually write applications with that. And then the voice user interface makes spoken human interaction with computer possible, using speech recognition to understand spoken commands and answer questions, and typically text to voice, text to speech. So a voice command device is a device controlled with a VUI. Examples include the Amazon Alexa, Echo Dot, Google Home, Google Mini, Siri, Cortana, just to mention a few. So these are all controlled with the voice user interface. Okay, so we move on to the user interface principles. The user interface principles. So we have principles that actually guide user interfaces. So you'd have to make sure that when you design an interface, it actually adheres with this principle. And the first principle is the principle of user profiling. So the principle of user profiling, establishing knowledge about the users, their demographics, the goal of using the product, and the tasks involved. So you actually profile the users you consider, like I said, your target audience. So you consider the level of knowledge, the user's level of knowledge, why are the user, why should the users, or let's say, why are the users using this particular product? Why should they consider this product? What tasks are they performing with this product? So you consider all these things while in the user interface design. And then the next one, we have the principle of metaphor. So the principle of metaphor gives the user instantaneous knowledge about how to interact with the user interface. So just like I said, you are even without a heavy manual, the user should be able to interact with it. For instance, I'm not sure you read Twitter manual before using Twitter. You never read a Twitter manual before using Twitter. So you are easily able to interact with posts on with on tweets. You're able to like tweets, you're able to retweet, you're able to share, and then just looking at the buttons, you know that this is what you should perform. This is what you should perform. Okay, so it should give the user instantaneous knowledge. As soon as the user sees an icon, the user knows that this is what the icon performs. For instance, a print button. As soon as you see a print button, you know you see a print icon, you know that this icon should print this page or whatever I've done. And then the next principle, you have the principle of exposure. So the user should be aware of all the functionalities made available to her via the interface. So mostly it would be nice to have every for instance, on your menu, the menu should contain the modules available on the application. And then the next principle is the principle of coherence. So a coherent principle, a coherent interface is logical and consistent and easily followed. So make sure there's consistency. And then we have the principle of state visualization. So each change in the behavior of the program should be accompanied by a change in appearance of the interface. So just like I said, the UI is just an abstraction. The UI, the user interface, is just an abstraction to what the system actually does. So the user interface just abstracts everything. It just abstracts everything. So if you make any change at the back end, you make any change at the infrastructure level, you make any change at the back end, you make sure that it is reflected at the UI level, so that the user, so that it doesn't change the behavior of the program. If the behavior of the program changes, you have to make sure that it reflects at the interface level. And then the next principle is the principle of shortcut. In order to achieve a task or get work done, the assessing method should not only be abstract but concrete too. So and then the next principle is the principle of focus. So some aspects of the user interface enjoy more attention than others. So I think there are a lot of let's say the application, mostly the application comes with the main function and other sub functions. So you make sure that the part that is mostly needed gets a lot of attention, gets a lot of focus. And then we have the principle of help. Help can be goal oriented, descriptive, procedural, interpretive, or navigational. An application roadmap is an example of a navigational help. Okay, so you can actually add usage examples, and then you add help pages to ensure that the user will be able to refer in case they are lost and then they need any advanced help. And then the principle of safety. The interface to develop a user's confidence by providing a feeling of safety. Okay, so you make sure that if a user is performing a function that, for instance, if we have, let's say, deactivate account button, okay, deactivate account button, you don't expect, as a UI designer, you are not expected to put the deactivate account button directly on the home page or direct at a place where the user actually accesses a lot of times, most of the time. You make sure you abstract it a little, you put it at a place where the user would have to find it. So, but it should be easy to find too. But you make sure that for instance, if the user clicks on it, maybe a warning modal should pop up the user, and then to warn the user before, and then the user would have to confirm before the account is deactivated. Okay, and then we have the principle of context. The user's activity should be limited to a well-defined context unless there is a specific reason to support a freedom to access more. Then we have the principle of user testing. Then the inevitable defect in the design of the user interface should be spotted. Okay, so we look at human factors in designing an interface. So there are some factors that you have to consider when you are designing a user interface. And these are human facing. So the first one is limited short-term memory. So if you present more than 7 items of information, there is a possibility that the user would be more liable to make mistakes. Okay, as humans we do have short-term memories. We do forget things. So when you are designing your system, you make sure you consider that as well. You make sure that, and then mostly it is much easier to remember pictorial stuff, graphical stuff. So instead of using a lot of words, you even if you are you would include a text. You make sure, for instance, on your menu, and then you have settings. You can include an icon, a settings icon there to show it, and then if it is home button, home text that is there, you can include the home icon there to facilitate it. Okay. And, you should also consider that people actually make mistakes. Users usually make mistakes when using systems, and as a result, if systems go wrong, inappropriate alarms and messages can increase stress and hence the likelihood of more mistakes. Okay, and then the next one is you have to consider that people are different. So people have a wide range of physical capabilities and therefore should not design with a self-assumption. Okay, so you have to have it in mind that people are different. Sometimes you design the thing, you think, Charlie, this thing is nice. You have a lot of people that will just commend you for that, and then definitely there will be other users who would have problem with that. You have to accommodate that as well. Okay, and then the next one is the interface preference. People have different preferences. Some like pictures, others may like text. So with the interface preferences, for instance, some users may like light mode, some users may like dark mode. If you have the capacity, you have to consider these preferences. Make sure that mostly one thing I always tell UI designers is that make sure that the system that you're actually designing is highly customizable. Mostly when I'm designing, when I'm creating a product, when I'm creating an application, when I'm working on something, I make sure that the thing is highly configurable. You make sure that the users can configure to their preference. You have to make sure the users actually are able to configure it to their preference. Just give them that give them that accessibility. Just allow them to be able to configure the application, and as well, and at the same time making sure that they are safe. Okay, so we come to software design. Software design. This is also another interesting topic. Software design. So software design is a systematic way of solving problems and planning for a solution. It deals with the components, functions to use, how to put them together to solve a particular problem. And then software design also include the low-level components, algorithm problems, and architect issues. Look at okay. So with software design, is the approaches the approaches that you use to bring to solve a problem, to solve a software problem. So the approaches that you use to create a software solution to solve a problem. That's the software design. So it actually deals with the components, the components of the system that you're designing, the functions that you're supposed to include, and how to put them together. So if you are solving a problem, they it comes with a lot of modules, and then how to put them together in a software that solve that problem. That is the software design. So software design also include the low-level components, the algorithm problems, and architect issues. And then, so look at platforms at software design. Take it into consideration. Okay. So why software design is important? Why software design is important? So why should we consider software design? And then one is modularity. Okay, so modularity actually involves splitting the project into modules. When you're working on a project, for instance, when you're creating a pharmacy management system, it actually has modules. You break it into modules, and then you make sure that each module performs one specific task. Each module performs one specific. So it simply means splitting the software project into small pieces, small tasks called modules for the simplicity of work. So splitting your critical software project into modules only makes it easier to work on every requirement of the project. It also gives the convenience of making changes in the future. And then if in case the requirement of your client changes, then you can go anytime go for restructuring a module, not the whole project. Yeah. So when you're able to design, you break it into modules. You break the software solution into modules, and then the requirement changes. It's very easy to it's actually very easy to accommodate requirement changes, because you have actually broken it into several pieces, and then each system functions separately, and then it's not entirely dependent on the other modules. Yeah. So it gives you easy finding errors in the modules, and then not the whole structured complicated code. Therefore, modularity makes the software simpler, and simplicity makes it effective. So this is why the software design is important. And the next one is maintainability. As soon as you consider modularity, you break your system into modules, it's actually easy to maintain. It is very easy to maintain. It's very easy. It's easily accommodates. In case there are errors, you can easily track those errors. You can easily debug the software at any time. So, and then the next one is trackability. So as the name says, it's the aptitude for tracking the flow of functions taking place in the software working. So it's very easy to track it's very easy to even track the usage, and then it's very easy to maintain. Okay, and then the next one is the flow of functionality and performance. Software design reflects the performance of the software application. A good software design effectively displays the flow of functions taking place while the software is running. Then the next one is portability. So yeah, so we come to the software design process. The design process, they choose is design process entails choosing the solution from a set of alternatives, giving the constraint towards a set of goals. So the design process involves choose. You would have a lot of alternatives to work with. So you would have to choose the best alternative for that particular solution you are working on. So we have a lot of for instance, you have a lot of software methodologies, software design methodologies, and you have software development methodologies that you can actually use, and then each methodology fits a particular project, fits a particular type of project. So you have to consider all these things. You consider the particular language to use, the infrastructures to use, and all that. That's what we term as the design process. So it can be divided into two phases, and then the first one is the diversification. So it's the phase of generating alternatives, and these alternatives are the solution candidates and are obtained from knowledge, catalogs, or previous experience. Okay, so first of all, you diversify the solution. You create several alternatives. You create several alternatives to choose from, and then sometimes you consider your previous experience. You know that, for instance, if you are considering performance, and let's say you want to work with a distributed system, you want to separate each module into microservices. You create different microservices for each module of the application or each feature. So you know, maybe from previous experience, you know that okay, using microservices increases the performance and all that. From that, you judge from your previous experience, and then maybe you read more on the best alternative before choosing the right alternative. And then the next phase is the convergence phase. So the designer chooses the alternative that meets the intended goals. The alternative selected will be the solution which will meet the constraint imposed by the problem domain. So with the diversification, you come up with a lot of solutions, and then the convergence, you choose the best alternative from the list of solutions that you came up with. Okay, so we come to what we call the enabling techniques. The enabling techniques, and the enabling techniques are what are also known as the software design principles. Software design principles, and they are the important concept in a variety of software design methodologies and concepts. So enabling techniques are established standards, approaches, and essential concepts that are recognized to produce usually good and sound software designs. So the enabling techniques or the software design principles, they are the established standards, and then the approaches and the essential concepts that are recognized to produce usually good and sound software designs. Okay, so we come to the design concepts. Design concepts serve as a foundation for more advanced methodologies to be implemented by the software designer. A collection of basic design principles has made, and they are as follows. Okay, so we have several design principles, and then with the design concept, it's as you said over here, the concept actually entails the various software methodologies that are implemented. Okay, so with the design principle, first of all, we have abstraction. So abstraction is the process of or consequence of generalizing a notion or an observable phenomenon by decreasing the information content of the idea or information, often to keep just information that is important for a certain goal. Okay, so we are designing a software. Well, for instance, there are actually a lot of abstractions that happens even at the code level, at the programming level, at the infrastructure level. A lot of abstraction happens. For instance, if you are working on a streaming app, you are working on a live streaming app, there are lots of things that you'll be using. Like for instance, you consider using Kafka, you consider using stream there are lots of things you might be using at the infrastructure level, but you would have to abstract all these things. You make sure that you actually the user would only see the part that is only important to the user. The part that is only important to the user, that is the part that you would have to show. And this technique suggests an element be represented just by its essential qualities that sets it apart from other items. And then with OOP, we have OOP abstraction. OOP abstraction to be abstraction in OOP as well. So you make sure that you only show the parts that are essential, and then makes it unique. You only show those parts. Okay. So, and then the next one is elaboration. Elaboration is the process of refinement, decomposing macroscopic declaration of function in a gradual method until programming language statements are reached, creates a hierarchy. One or more instructions from a particular program are deconstructed into more detailed instructions at each stage. Okay, so with this one, you make sure that each module is well explained. Each module is well explained. And then the next one is modularity. Just like we said, you break the system into several modules, several pieces, and then each piece perform a separate task. It's a particular task, it's a specific task. And then this process is called modularization. Okay, and then the next one we have information hiding or encapsulation. So the models should be specific and then constructed in such a way that any information contained within them is inaccessible to other models that don't require them. Okay, so with this one, you make sure that you hide as much information as possible. Like for just as I say, you make sure each model is entirely is independent. It's not entirely dependent on the other models. So definitely, each models would have to perform a specific task. And then if the module contains information that's not needed by any other module, you'd have to hide those information, and then they should not be accessible by the other modules. So just like in OOP, so you only you hide the parts that are not needed outside, and then you only show the parts that are extensible. You only show the parts that are extensible. Okay. Then continue with the design concept. You have the software architecture. So it refers to the software general structure and how the structure maintains a system conceptual integrity. And then we have the control hierarchy of the program, and then we have the data structure, and then the software procedure. So the data structure, for instance, how you represent each data. How do you represent each data? So that's the data structure. Okay. So we come to design consideration. Design consideration. With the design consideration, these are the things there are a lot of things you have to consider when designing a software. When designing a software, there are a lot of things that you have to consider, like compatibility. So you have to consider that the system will be compatible with devices, and then mostly it's dependent on what you are working on. If for instance, if you are working on an Android app, specifically an Android app, you make sure that it will be compatible with at least it should be compatible with older versions of Android as well. And then as time goes on, if you are making any compatibility changes, you have to make sure that the users are aware of any compatibility changes. And then mostly a month or mostly a year before you do the compatibility breaks. And then if you are adding any feature that will make it backward incompatible as well, you have to consider that as well. So mostly with because of compatibility issues, we have something we call semantic versioning, and then that one is quite obvious. And then for each version, if it's a minor version, that there will be no compatibility issues. If there are patch releases, there were bugs that were fixed, and if it's a major release, then that there will be compatibility issues. Yeah. And then the next one we have is the maintainability. So considering maintainability, I'll just combine maintainability and then modularization. Make sure to make sure the system is maintainable. So ability of the software to be restored to a specific condition at a specific period of time. So you employ several methods that will make sure that the system is maintainable, like using modularization, consider modularity, and then security, ability to endure host attacks. And then mostly when you're designing a system, you have to consider the security as well. You make sure that there wouldn't be any XSS attacks, any SQL injections, and all that. You have to consider all those things. And then usability. So the software user UI must be usable by the target audience, as we discussed. And then reliability. The system should be highly reliable. And then the ability of the software to perform its functions under stated conditions. So the system should be highly reliable. You make sure that there wouldn't be any downtime. There wouldn't be at least zero downtime. If you are upgrading a system, you can actually consider using some infrastructure tools like Kubernetes and Docker. You make sure that there will be zero downtime whilst updating or upgrading your system. And then extensibility. So the system should be highly extensible to the extent that you can actually add new features to the system without actually making major changes in the architecture. And then this one is made possible mostly when you modularize your application. And then reusability. Definitely, that modularity actually comes with a lot of benefits, like maintainability, extensibility, reusability, and then fault tolerance. Modularity actually comes with a lot of so you're able to reuse. Make sure you should be able to reuse some features, some function. If you create classes, you should be able to reuse them. And then the system should be robust and the ability to tolerate unpredictable input. So this one, you make sure that you have tested the system, you rigorously tested the system to the extent that it. One thing is that you shouldn't trust users. You can never trust users. That's, as a software engineer, as a software developer, you should never trust users. Users cannot be trusted. So you make sure that if the system expects numbers, if the system expects positive numbers, enter a negative number and see how the system behaves, because a particular user will enter a negative number. So you have to test it rigorously. And then packaging. So boxes and printed materials should conform with the target audience. And then when you're packaging your system, if you are packaging for Windows, you know that it should be an Excel file. Okay, should you include an installer? If you're packaging for Linux, there are lots of Linux distros. So which distros are you considering? If you're considering Arch Linux, then you should make sure that the users would be able to install using Pacman. If you're considering Debian systems and Ubuntu systems, the user should be able to install them with APT. Okay, and then modulation. So implementing and testing the components in isolation, and then we have the fault tolerance. And then for a system to be fault tolerant, then it should be a distributed system. For distributed systems, even if one system goes off, the application continues running, and that's why it's very difficult to debug partial failure in distributed systems. And then, but one particular advantage of distributed systems is the fault tolerance. So even if one particular system fails, the other components are still working, and then you'll be able to work on it, and then fast you move on. So ability to recover from component failure. Okay. Then we come to the modeling language. So the modeling language is any artificial language that can be used to express information in a structure. That can be used to express information in a structure that is defined by a set of rules. It can be graphical or textual, and then they are classified into static view or dynamic view. So we have the modeling language. Artificial language doesn't mean artificial intelligence. So they are just ways that you express, you actually define the structure of the system you are designing. So like using UML diagrams to explain the flows, and all, like using flow charts and all that. We have this thing called flowgorithm. So this application called flowgorithm for designing flow charts for your application. So we have the static view and then the dynamic view. So the static view, they are mostly graphical. They describe the major components, show how they are interconnected. And then with the dynamic view, it actually shows the behavioral aspects. So the static view just explains how the system is, and the dynamic view explains how it behaves. So the first one is just the interface, and then the dynamic view is the behavior. Okay. So examples of the static view is ADLs and then ERDs, and then the dynamic views, you have the UML diagrams, flow charts, data flow diagrams, etc. Okay, so that is the end of our presentation. We learned about user interface design, software design, and then software design principles. And then just like you said, when you're designing a system, when you're designing your system, you make sure that you consider a target audience, you make sure the system is highly usable, and then you employ the best practices to make sure that your target audience will easily be able to use your application. Thank you very much for the time. Bye.